Hello. Today we're going to talk about how we find the limit definition of the derivative. Let's start by giving myself an xy axis and giving myself some function like this. Give myself 2 points on this function, let's say one right here and one right here. This first one I'm going to label as x sub 0. Second one I'll label as x, and then likewise over here this is going to be f of x sub 0, and this is going to be f of x. Alright, and if I was to connect these two, I would form my secant line. And if I wanted to find the slope of the secant line, I would use the point slope form to say that y minus f of x sub 0 equals m times x minus x sub 0. And if I wanted to solve for the slope, I would divide both sides by x minus x sub 0, x minus x sub 0, and I would get the equation we're all pretty familiar with, m equals f of x, which is the same thing as y, minus f of x sub 0 over x minus x sub 0. But I want to find the slope of the tangent line at my point x sub 0. So I have to ask myself, how am I going to do that? I already have my line drawn here with my secant line, so if I can make my second point really close to x sub 0, I'll essentially have a tangent line, and I can use this formula to find its slope. So to kind of see it visually is that every point on here is me getting closer and closer to x sub 0. And along the way, I could keep on making these lines, so it would be a line like that, and like that. But eventually I'm going to get really, really close, so I'm essentially right next to x sub 0, and then I'll have the same connecting line like we did before, only this time it's my tangent line. Tangent. So then we're going to kind of rewrite our equation to represent this. Since my second point is approaching x sub 0, I'm going to say that the slope of this line is the limit as x approaches x sub 0. And then we'll have the equation of our slope, f of x minus f of x sub 0 over x minus x sub 0. And then this is how we find the slope of our tangent line.